This is practice A for section 8.3. What theorem can you use to show that the quadrilateral is a parallelogram? So all of these shapes are going to be parallelograms, but you need to know why. What marks are shown that indicate that it's going to be a parallelogram? Well, the information that you need is in your theorem packet or in your notes. There's 4 theorems. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is going to be a parallelogram. So what does that look like? Both pairs of opposite sides are congruent. Where do you see that? This is theorem 8.7. Both pairs of opposite sides are congruent. That's what makes that a parallelogram. Also, if you look at this example, these opposite sides are congruent. These opposite sides are congruent. So you can use theorem 8.7 here also. That's the first way that you can show that a figure is a parallelogram. If the opposite sides are congruent, it's definitely a parallelogram. Okay, the second way we'll look at is theorem 8.8. It says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So where do we see that? Where do you see both pairs of opposite angles congruent? Right here. This is theorem 8.8. Also, notice how these opposite angles are congruent, both pairs. Those ones are kind of easy because they're converses of the theorems we looked at in the previous section. This one's a little different. It says if you have one pair of opposite sides of a quadrilateral congruent and parallel, then the quadrilateral is a parallelogram. We need one pair of opposite sides congruent and parallel. That's what this looks like. The slash marks are the congruent marks. Those colored in triangles are the parallel marks. These are opposite sides. They're congruent and they're parallel. That's theorem 8.9. Okay, now our last way is also the converse of a theorem from last section. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. What does that look like? Well, the diagonals are bisecting each other here with those marks. So that's theorem 8.9.